Here's a model that's been explained in some detail in the notes. Let's just look at the model. Okay, here we have, now this is a model of stock market behavior, and let me warn you, this isn't going to help make you rich in the stock market. It's a pretty crude model, and it doesn't necessarily apply. But it's an example of how we might model the stock market. Okay, what we have is today's situation, up, down, the same. Tomorrow's situation, up, down, the same. Now P1 is the probability that the market is up today, P2 that the market is down today, and P3 that the market is the same today. We want to find the probability that the market is up or down or the same tomorrow. The pluses mean, of course, the probabilities after transition. Now, we're going to say that probability that the market is up tomorrow is going to be 1/4 the probability that it's up today. That means that if we know the market for sure is up today, then there's only 1/4 probability that it's going to be up tomorrow. And if it's down today, there's a 1/2 probability that it'll be down tomorrow. If it's the same day, there's a 1/4 probability that it will be up tomorrow. And I think I said that wrong, so let's say it again. If it's up today, there's a 1/4 probability that it's up tomorrow. If it's down today, there's a 1/2 probability that it's up tomorrow. I think I might have said down before, but these are the probabilities. We're getting the probability that it's up tomorrow. So we take 1/2 the probability that it's down today. That'll be the probability. That'll add to the probability that it's up tomorrow. If it's the same today, we're saying there's a 1/4 probability that it'll be up tomorrow. So when we add these three together, if we don't know for sure whether it's up, down, or the same today, all we have is probabilities of being up, down, or the same today. Then we can predict what the probability is going to be that the market is up tomorrow. And we get this by simply multiplying the probabilities here. Now you see that then the probability of up tomorrow is equal to this, and we represent that as follows. P1 plus means probability that it's up tomorrow, because P1 is the probability of an up. And 1/4 the probability of up today is 1/4 P1. P1 again is the probability of an up. This is probability of up today. This is probability of up tomorrow. Plus 1/2 of the probability that it's down today. P2 is the probability of being down today. And P3 is the probability of being same today, and we multiply that by 1/4. We add these up, we get the probability of the market being up tomorrow. So now we have the model that we see. Okay, this first row represents the scheme that we just looked at. The 1/4 is a probability that it's up today. That'll multiply the P1. The 1/2, sorry, 1/4 is not the probability. 1/4 is multiplied by the probability that it's up today. Let's clarify. 1/4 is the probability. If the market is up today, then 1/4 is a probability it's going to be up tomorrow. So 1/2 is a probability that if the market for sure is down today, it'll be up tomorrow, and so forth. So the 1/4 that we have here goes here, so it'll multiply P1. The 1/2 that we have here was multiplied by P2, so we put it here, so it'll multiply P2. And there's a 1/4 down here that's down off the screen. But we see that it's multiplied by the probability the same today, which is P3, so it has to go here. Then we do the same thing for the probabilities that the market is going to end up down. This says that we take 1/2 times the probability that the market's going to be up today and add that into the probability that the market's going to be down tomorrow. This tells us that if we know for sure, if this probability is 1, and these are both 0 then, because the probabilities do have to add up to 1, if this one is 1, that means that the market is for sure up today. This says that there's a 50-50 chance that it'll be down tomorrow, a 1/2 chance. This says that if we know for sure that the market is down today, there's a 1/4 chance that it'll also be down tomorrow. And that if we know for sure that it's the same today, there's a 1/2 chance that it'll be down tomorrow. And we can interpret the third line similarly. So that's the content of this model. We can do the same thing with these probabilities that we've done with the stable and demented probabilities. It's just like a stable and demented. We got so many probability units that it's up today, down today, same today. That's just like the total number of sane, demented, and borderline people. And we multiply those by the probabilities that they're going to make certain transitions. Only 1/4 of the sane people stay sane, 1/2 of the demented people become sane, 1/4 of the borderline people become sane. This is a sane, stable, sane, demented, and borderline model. Acts just exactly the same. We say that matrices of this nature are stochastic. Probability matrices like this are stochastic. Let's look at what the first column of this matrix means. The first column says that 1/4 of our probability of being up today goes into the probability of being up tomorrow. 1/2 the probability of up today goes into the probability of being down tomorrow. 1/4 of the probability of being up today goes into the probability of being the same tomorrow. Okay, because all these numbers multiply the probability that we're up today. In the first row, that contributes to the probability of being up tomorrow. The second row, it contributes to the probability of down tomorrow. And the third row, to the probability of being the same tomorrow. These are all the probabilities that act on the probability of being up tomorrow. Now, if this was the number of sane people instead of a probability, it would be fairly clear that this is 1/4 of the sane people go to sane, 1/2 go to demented, 1/4 go to borderline. These numbers account for all the sane people. Similarly, these numbers account for all the probability that the market is up today. And they have to add up to 1 then. Okay, they account for all the probabilities in one item here, on one category. They have to add up to 1. These probabilities add up to 1, and these probabilities add up to 1. That gives us what's called a stochastic matrix.